Okay, this is Precalculus, and we have the Remainder Theorem. The Remainder Theorem says if you have a polynomial divided by some factor, and as long as that factor is to the degree 1, there's a little trick that can be done. First of all, you want to start with the x minus 3 is going to actually be minus 3, so that's going to be a positive 3. The Remainder Theorem says you can plug that bottom 3, the negative 3 turned into a positive 3, into the original polynomial, and you can get what the remainder of that is going to be just by plugging in that number. So if we take the positive 3 and we put it in for the x's, it's going to be 3 to the third minus 4 times 3 to the squared minus 5, and it's going to give us a negative 14. The other way to do this, to find the remainder, is to do regular division by synthetic division, or even long division. But when we do the synthetic division in the same procedure as you always would, you're going to get the same remainder there on the bottom right is the negative 14. They're going to be exactly the same. It's just saying that there's two different ways to get the same answer. So we'll look at another example here. Again, you have the polynomial on the top divided by some factor, and that factor is x minus 2. You take the negative 2, but it's actually, you're looking at it the same way you look at synthetic division. It's a minus 2, which becomes a positive 2. You plug that 2 back into the original polynomial, and that's going to yield for you a negative 2. Now, if you would have done division or synthetic division, you would get the same remainder of negative 2. It is one step more efficient in calculation because you only have to multiply by what's actually in the polynomial. In synthetic division, you have to add that extra one step. There's a 0 there on that synthetic division where it's extra because there's a missing x to the first. Again, we'll look at one more example here. This one's just a little harder because the remainder is bigger, but it's the same principle. On the x minus 4, that's a minus 4, giving you a plus 4. You plug the 4 back in the original polynomial, and that'll give you a 93. Now, again, you can see on the synthetic division, you have to add in that extra 0. So where it's 1, 2, 0, negative 3, that extra 0 is added in because in the original polynomial, there's no x to the first. It's a missing spot. So it's more efficient to do the remainder theorem because you're just plugging in what actually exists. You don't have to worry about that missing spot. And it takes up a little less time to do the remainder theorem. It takes a little more time to do synthetic division. But again, either way, you're going to get the 93 as remainder for either one of those. So the remainder theorem, using it in the original polynomial, is just slightly faster, and the synthetic division is slightly longer. By that, you have to remember that missing piece where there's the 1, 2, 0.